Hello, I am Aditi Kumar and welcome to another learning session related to machine learning. We know specially machine learning is used to build the learning capability in computer, in machine. But what are the number of ways we can make computer learn? Or maybe what are the categorization of learning problem within machine learning? Let's understand better and better with the proper categorization of these learning problems. There are certain categorization of learning problems within machine learning. So, my first categorization here is, I can say the major learning problems includes three main category of learning problems. So, first one here is your supervised learning, second one is unsupervised learning, third one is reinforcement learning. So, specially the supervised learning is wherever we are having our input variable and label. Label means our output. Both the combination is from the data, our historical data is available with us. Then the problem statement or the maybe I can say the learning algorithm we will put on the top of this data will be supervised learning. You can think for any supervised learning problem then according to input data. If I am talking about unsupervised learning, we don't have any output or maybe I can label the data, only input we are having. We can only use a pattern or maybe I can say we can only just build a pattern or a relationship among the data whatever available with us, which is completely the input that I can say. There is not any proper label. And my third category here is reinforcement learning. Here we don't have any historical data. We have only one environment present. No input data, no input historical data. Only there is a environment, I can say the surrounding available with our with our maybe I can say our model, our algorithm. Our algorithm will gradually try to build the knowledge from that environment. There is a certain criteria, there is a certain way the reinforcement learning problems are working. There are multiple models I can say or maybe algorithms under each category, supervised, unsupervised, reinforcement learning, but I am not basically specific to any categorization for now. But again, these are the major category of learning problem within machine learning. But except that, there are some other categories. Let's dig dive into these categories also. My second, I can say the area of learning problems I divided here into hybrid learning problems. Here, why these are basically hybrid learning problems, this is not specific to any type of major learning problems. It is not specific to specifically supervised or unsupervised or reinforcement learning. This is maybe combination of two, or sometimes it is more than two, or maybe it is a hybrid approach we are adopting. For example, semi-supervised learning, it is some cases it is used supervised plus unsupervised. For some of the data set we are using supervised then unsupervised. Same like self-supervised learning, then multi-instance learning. These are the basically I can say some hybrid learning problems. There are certain mathematical algorithms, I can say specific algorithms coming under this category, or maybe sometimes though this is basically a hybrid learning problem, but still we are using the major categorization algorithms and combining it into a common hybrid approach, I can say some hybrid or composite algorithm, then we are putting on the top of our input data. But again, it is not specific to any particular data set, then again it is specific to problem statement. We will see what is our problem statement. Can we basically solve the problem using only supervised or only unsupervised? If it is basically not possible, then maybe we can think on some hybrid approach. These are basically the major categorization of the hybrid learning problem. Again, these are the derived from our major category. Then my third scenario here is statistical inference. Basically, inference is a term is used maybe it is basically related to decide something, to take decision, If I am talking about machine learning, in machine learning there are two type of inference is happening at a time. At a time means I can say within a particular model. So first inference is fitting the model, and second is prediction. There are two type of decision actually we are taking within any machine learning model. So according to this perspective, I can say this phenomenon, we are basically having three concept under mathematical inference. One is inductive learning, second one is deductive inference, then third one is transductive learning. That are the three categorization. It is a certain basically concept, mathematical concept behind each category. We can maybe dig dive into that in our later sessions or later videos. But for now, there are the three main categories coming under statistical inference, which is basically I can say the sub area of a learning problem within machine learning. Then the last categorization I did here, other learning techniques. Other learning techniques, I can say these are also, I can say, some derived learning techniques which is being derived from our major category, supervised, unsupervised and reinforcement learning. But again, these are major other categories of learning problem, which is basically I can say is a composite learning problem. For example, multitask learning, active learning, online learning, transfer learning, ensemble learning. These are the major composite learning problems. If I am talking about ensemble learning technique here, it is basically dealing with the, I can say, the output derived from multiple individual models. That might be from supervised, from unsupervised, but again this is basically it is derived from multiple individual major category of learning models. For example, transfer learning, if I am talking about transfer learning, then transfer learning means whatever the learning is happened for a first model, maybe instead of start learning from scratch in second model, we can use that particular learning whatever we gained in our first model, we can transfer that. Then starting from that particular point, we can start learning again for the rest of the component or rest of the part or rest build the additional knowledge top of that. So this is basically the categorization of other learning techniques, which is basically derived from our major category. So if I am talking in a pictorial way, so basically major category here is supervised, then unsupervised, then reinforcement learning. Here input plus output, here only input, here no input. If I am basically combining these two or three, maybe I can say we are basically deriving, or maybe I can say we are deriving basically 2 or 3, then we are basically deriving other category of learning problem. I can say here hybrid approach. For each category of the machine learning problem or maybe learning problem, we are basically dealing with our statistical inference. Where we are using basically multiple models at a time, or maybe then we are basically deriving the output from multiple models output at last. This is basically the ensemble technique. Then there are again each category or maybe each learning problems consist of lots of algorithm within that. A particular category contains multiple algorithms into that. Definitely we will have different session for each category with the mathematical concept and application, but again these are the some high level terms. So supervised learning, unsupervised learning, reinforcement learning. These are basically the major category of learning, and the hybrid approaches basically I can derived from any two or any three, or maybe it is a composite. I'm not specific to any specific algorithm, but again this is basically derived from these three major category. And statistical inference, basically I can say this is the concept used in each and every machine learning model. And finally the ensemble technique, or maybe I can say transfer learning. These are the basically other category of the learning, basically uses multiple algorithms from major categories, and basically combining and or maybe providing a very robust output as a final result in the real world scenario. That's why I thought I will basically, before starting any specific machine learning algorithm directly, I would go through the learning criteria or learning categorization behind machine learning, so that then maybe I will start building the videos or maybe content for any specific machine learning model algorithm. For example, if I am talking about supervised, regression and classification are the two category, and if I am talking about regression, multiple basically the I can say algorithms coming under or solving the regression problem statement. So definitely I will start preparing the content for specific to any special algorithm with a mathematical concept behind it, and how we can apply in a real scenario, or maybe what can be the ideal scenario for the application of this particular algorithm. Thank you very much for watching this particular video. Please do subscribe my channel, or like and share this particular channel, so that it will be beneficial for other also. Please put comment under this particular video, so that I can get some information how basically that video is useful for you. Thank you once again for watching this video.